Bismillahirrahmanirrahim. Assalamu alaikum. Today we will play with Newton's Cradle. Newton's Cradle is a device that consists of a row of 5 metal balls positioned to just barely touch one another, suspended from the frame by thin wires. Newton's cradle demonstrates the principle of conservation of momentum, that is mass times velocity. This principle states that when two objects collide, the total momentum of the objects before the collision is equal to the total momentum of the objects after the collision. Potential energy is energy objects have stored either by the virtue of gravity or of their elasticity. Kinetic energy is energy objects have by being in motion. In a Newton's cradle, ideal balls are made out of material that is very elastic and of uniform density. Elasticity is a measure of material's ability to deform and then to return to its original shape without losing energy. Very elastic materials lose little energy. Inelastic materials lose more energy. Stainless steel is a common material for Newton's cradle balls because it is both highly elastic and relatively cheap. When all 5 balls are at rest, each has zero potential energy because they cannot move down any further, and zero kinetic energy because they aren't moving. When the first ball is lifted up and out, after the ball is released, its potential energy is converted into kinetic energy during its fall because of the work gravity does on it. When the ball has reached its lowest point, its potential energy is zero and its kinetic energy is greater. Because energy can't be destroyed, the ball's greatest potential energy is equal to the greatest kinetic energy. When the first ball of the Newton's cradle collides with the second, the first ball stops, but its momentum isn't lost, just transferred to the second ball, then to the third, then to the fourth, until it reaches the very last ball. You witness this conservation of momentum as the last ball swings into the air with nearly the same momentum as the first ball. All the balls have the same mass. Each ball has a mass of m. The initial velocity is taken as v. The initial momentum is equal to mass times the velocity, that is mv. The initial momentum is equal to the final momentum of the last ball, that is also equal to mv, since the mass of the ball is the same and the final velocity of the last ball is almost equal to the initial velocity of the first ball. Thus, if two balls are lifted into the air on one end of the string and released, then two balls on the opposite end will swing in response. Thus, if initial momentum of the first two balls is equal to 2 mv, the final momentum of the last two balls is also equal to 2 mv. Hence, momentum is conserved. When three balls are lifted into the air on one end of the device and released, then three balls on the opposite end will swing in response. If the initial momentum of the first three balls is equal to 3 mv, the final momentum of the last three balls is also equal to 3 mv, hence the momentum is conserved. Now let's try it with 4 balls. The 4 balls swing. The initial momentum is equal to 4 mv, where m is the mass of the ball and v is the velocity. Final momentum of the last 4 balls is also equal to 4 mv. Momentum is conserved. If we study the system completely, there is friction inside the system. When the ball was released from a certain height h, it had gravitational potential energy equal to mgh, where m was the mass of the ball, g was the gravitational acceleration, and h was the height of the ball. When the ball moved downward, it gained velocity. Potential energy got converted into kinetic energy, which is equal to half mv square, where m is the mass of the ball and v is the velocity of the ball. The energy of one ball got transferred to the other and then to the next, causing a compression wave. This compression wave caused loss of energy in form of heat and sound. The last ball is unable to attain the same height as the first ball, and eventually the system loses all its energy and comes to a rest.
Thank you for watching. Allah Hafiz.